Is Bart Brosens. I work for Sigasi about 3 years now, and I mainly support our customers. And before that, I was working as a VHDL designer myself for ASIC and FPGA applications, and I was a user of Sigasi Studio. So welcome, and thank you all for joining this tutorial. Today I'll talk about how you can be more productive when working on the design and verification of VHDL, Verilog, SystemVerilog or mixed language projects. Digital design is difficult. You have to deal with clock domain crossings, reset domains, state machines, the hierarchy of your designs, and these are the things that you need to focus on as a developer. There are a lot of good tools that help with getting your code on the silicon. And whether the silicon is an ASIC or FPGA, these tools focus on the end result. They start from your AGL code, which should be syntactically correct. However, how this code is created is not of a great concern for most of these tools. You, as the developer, you want to spend as little effort as needed on the practicalities of getting the source code correct so that you can focus on the creative aspects of your digital design. And to be more efficient in your development work, you can rely on the use of tools that help you to be more productive. For instance, you might want to efficiently write error-free code. Maybe you need to follow company guidelines for the style or naming conventions in your projects. You might want to be able to explore great sets of code. You have a lot of source code and you want to dive in it to search for specific issues. And probably you also need to deliver documentation of your code. So in this tutorial session, I'll focus on these topics and I will show you how our company's product, Sigasi Studio, can help you with this. So to edit your code efficiently, you need a tool that gives direct feedback, that provides syntax checks that are language aware, and also that provides intelligent content assist. So in a classic approach, you're editing your source, you're saving your source code, you're running a tool maybe through a makefile and you get feedback from that tool. Then you have to find where is the cause of an error message that you get. You have to edit the source again and then you run the tool again until you have or you're able to compile your code without errors. This is a long feedback loop that requires a lot of mental energy. All these context switches between editing your code and running the tool, looking at the error messages. So if you have direct feedback, so while you're editing your source and you immediately see where the syntax errors are before you even save your source, that's a great speed up of your and a better use of your time. Let's see how this can work in practice. I'm opening Sigasi Studio, and the first time you open Sigasi Studio you will get two tutorial projects, a Verilog tutorial and a VHDL tutorial. On the left hand side here you see the project explorer where all the files of the projects are. Centrally you have the editor view. On the right there are some outline and hierarchy view, which we'll look at later. And below here we have a problems view where there is a nice overview of all the markers on your projects. So these example projects have a lot of comments and to-do statements that help a first-time user to go through the projects and also get to know the Sigasi Studio features. So for this demo I'll use this Verilog project and we'll briefly go through some of the files. So a first error marker that you see, that we have a missing closing. At the bracket, you see the error marker becomes gray, and once you save the file, the error marker also disappears. So what happens if you type new errors, for instance? So while typing, you see that error markers do appear and indicate that there is an issue with the code there. And as soon as you correctly finish a new line, the error marker goes away. So this is the fast feedback that can really help you to be more efficient when writing code. It doesn't get to the compile stage with an external tool before you notice any syntax errors or other issues with your code. You immediately get that feedback, and that helps you to get the syntax of your file right the first time. Something else is that this file isn't looking very nice, so what helps is formatting your file. Then it's easier to understand, so you can right-click source and click format, or press Ctrl-Shift-F, and when doing so you see a much more readable file. What also helps to recognize code is a semantic highlighting we have here. So depending on whether you have a keyword or something else, there will be different colors. Another very useful editor feature is something like block select. Like here we have a few vector width indications below each other, and you might want to change them at once in a block like this. I'm skipping a few things, we'll come back to those later. Intelligent autocomplete or content assist is very useful. So let's insert an always statement. I start typing always, I press Ctrl space, and then you get a list of the possible completions. And in here, let's add a posage clock, and the name of the clock should be updated here. Now here we have an empty always statement. We also have a few assignments that could be placed well within that always statement. So when you select a couple of lines and you press the arrow key while you keep the Alt key depressed, you can move a few lines. So that also makes it easy to restructure your code to efficiently move lines around. You don't have to cut and paste things, you can just move them over using the arrow keys. And again, if I format, it looks a bit nicer again. You also want to be able to quickly select code and either comment or uncomment that. You can do so pressing the Ctrl/ key. And if I format again, you can also see what actually is in here. Let's jump to the next issue. If I press Ctrl dot, we will jump to a warning that we have here. And it tells us that the parameter here is missing a default value. Let's put the default value to 8, and while doing so, the marker also disappears. Let's look at the next file here, and then let's save this one first. You see the gray markers will disappear when saving a file. So it also helps you to indicate which lines you changed before saving a file. And here that was probably the result of the formatting we did. So in this second step, we again have some issues. I'll jump directly to them using the Ctrl dot key. Here is a wrong assignment. So the assignment operator should just be a single equality sign. Let's save the file, and there are still other errors in the file. I'll jump to those. So here we see a warning, and then the actual error marker is here. So there is a duplicate formal port because someone made a typo, and things like that you will see immediately while working on the code. So imagine you're typing something wrong, and the indication is immediately there. So now here on top we see we have no more markers in this file. Let's look at another one. In this case we have an include statement, but the include is failing. If you press the light bulb, you see a quick fix because the pixel buffer header file has been found somewhere in the path of your project. It's actually in the includes folder here, and now you can choose a quick fix which will automatically add this folder to the include path so that the include statement can be found. Something else that's very useful then, specifically with SystemVerilog projects, is a preprocessor view. So this view shows you the file after preprocessing. So here you probably see that not much is in the pixel buffer header file. So let's have a look if that is really the case. I press Ctrl, I click on the hyperlink, and we jump here, and yeah, probably not a lot of actual code was here. So you can also scroll through the preprocessor view, you click a line, and you see that those lines are highlighted there. So it's very easy to see the result of using the preprocessor in SystemVerilog. For another example of intelligent content assist, I'm going to look at the VHDL process. So there is no preprocessor in VHDL, so we can ignore that view. And in here, I'll also quickly format the file. There is an example here of an unused signal. Things like that are also indicated. It might be an indication of a bug somewhere, or you forgot to declare something. We'll look at that further. In VHDL it's also important to have a sensitivity list, right? So here is a signal missing. We'll add that one to the list. There is another syntax error. This one can be resolved with a quick fix, but you quickly see what is going wrong. And for instance, here we have the indication that we should add a case statement. So there was already an enumerated type a bit higher. Let's go back to there. So my type, we see a signal of that enumerated type. And when you press Ctrl space, you can immediately add a skeleton for a state machine that is following this enumerated type and using that as the state type. That's also very interesting if you quickly want to build up state machines. And actually there is a bit more, but we'll see that in another file. So here we have another error where the assignment operator was not correct for the output port. So the next file here talks a bit more about the state machines, or demonstrates it a bit more. Let's jump to the first marker. Again, probably we have a process with a bad sensitivity list, which we add like this. And then here we have a case statement, and the error here says that not all cases are covered. So the reason for that is if we check the declaration of the state variable, it's actually in a different file, which I'll show here. So the state type is declared here, and then if we go back here, the waiting state, which we have here, is missing from the state machine. So also for that is a quick fix. If I press add missing choices, you see the error marker was grayed out, and here now we have a new waiting state. Something else is wrong, because in this almost ready state there also is an error, because there is no almost error in the enumerated type declaration, and that's something that also can be added using this quick fix here, and almost ready is automatically added in this file. Now let's save all files for now, and then you see the error marker here is also gone. Now we just have one more warning, so the state does not have outgoing transitions, it's a dead state, and the program also warns for that. Oops, I did something wrong. Undo, yes. I replaced this new enum with a space by accident, and you saw the error marker pop up here immediately, which is really helpful if you do that by accident in your projects. Something else that can be really useful is the renaming. The state T name here and here is maybe not the name that you want to have, so you can press Shift Alt R, or you right click and choose refactor rename element, and for instance let's call this type fsempty, and immediately not just where the declaration is, but also where the type is used, the name is changed. So if you need to refactor some code by renaming elements of your design that appear in multiple files, that can also be done easily this way. Then something else that's for VHDL projects very useful, that's the use of libraries. So Sigasi Studio supports, helps you with getting your design files in different libraries. Here, for example, we try to use a library mylib. There is an indication that it's not available, this library. We also see code that is not found in the design, and certainly not in my library. So what you can do here is you select this, and actually the button is over here. Let's search for the clock generator in the workspace we have here. So if we search, there is a new view, and we see that in a folder mylib there is a file clock generator where indeed the clock generator is declared. So this is the mylib folder, and now I can right click the folder and I choose to set the library. Now instead of typing the library myself, we can easily assign the folder to a library with the same name. So I'm selecting that. You see here, and if we open the folder, the clock generator now is in mylib, and in the end mylib here is found, and also the clock generator here, there no longer is an error. This warning indicates that the single clock is never read. Of course, we're just generating it here and not doing much else. If you want, you can also, like this, suppress warnings, and then the warning also will disappear from the problems you have here. This can also be used to exclude files. For instance, here we have a very troublesome Verilog file. We can right click and unmap it or exclude it from being built, and then you'll see that the problem view now is clear of any error. If you want to quickly find out about the remaining problems, you can just double click a line here, and then you go to the editor, and here you can immediately, using this quick fix, update some things. And once you save the file, the problem is also removed from the problems view. So with that, I wish to conclude this first demo part. So let's now have a look at code browsing. So while I was demonstrating the tool before, you've seen that I clicked various things to open code, to navigate to places. Already I have used the hyperlink, so when keeping the control key pressed, you can click any object and jump to the declaration. That's really useful to get to know the code, but you don't have to click on it. You can also just hover over your something that is used, anything in your code, and the hover pop-up will show you the information like the type or any other declaration. And then there are in Sigasi Studio multiple views available that give you more insight in the code. We have seen the problems view, but there is a lot more than that. So we'll return to Sigasi now, and we'll continue the demo there. So to start, I'm going to close a few of the files we had open, and let's come back here to this first file. So certainly if your project becomes a bit larger, it's very important that you have a tool that helps you to navigate efficiently through your code. And here, for instance, we can navigate by just putting the cursor on the use of GradX here. We press F3 and we jump to the declaration of the GradX wire. So these are not far apart, but this also works over multiple files in your project. You can now press the arrow left key with Alt, or just here this icon in the toolbar to jump back. So this helps you to navigate backwards and forward through your code, through different files, in effect just like you're browsing a website. So also if you press the Control key and you can hover, then you see this becomes a hyperlink, and you just click on the hyperlink and you jump to the declaration. You can come back in the same way. I just pressed Alt left now. You can also go forward and back again using the cursors. So efficient and easy navigation through your source code is really important if you're looking for something and you want to go back where you came from afterwards. But maybe you don't have to go look for something. You can also just hover, and here you see that when you hover over GradSQ, we see what it is. Obviously we see it here on top of the line. There is also a comment behind that, and you see that the comment is also copied here in the hover. So that's really helpful to have the extra explanation where you need it, where something is used. Also, it's often not just about finding where something is declared. You might also want to know where something is used. So for this you can search for the references, and here we end up in the search window again, where I can click on a reference and then you see we end up in a different file. And vice versa, if I press Ctrl and I hover over the counter and I click it, then we jump back to the declaration where we came from. So I can now just go back to the second file. Then there are some other views that can help you to navigate more through your project and through your files. The first view we have here is the outline view. So this gives an overview, a high-level overview of the contents of your file. So I just clicked the ports maps, or the port declaration, that is. You can click on other declarations for wire to immediately jump there, to a module instantiation that we have here, to all the different elements that compose your source file, and that helps you to navigate through a source file, certainly when it's a bit larger. And this view also dynamically adapts to the content of the active editor. So if you select a different file, you here see we have a different overview of this file. Now what you also can do is you can choose a module and set it as a top level, and then in that top level you can see the hierarchy in the hierarchy view. Now the counter here is just a module that was used in another part of the design, we'll probably have more luck setting the test bench as a top level. And then here you see that there is an instance, and you can navigate through the files here. This one is an unresolved instantiation still. So, and the reason that this one is still unresolved is that here we have a Verilog project, but actually it's a mixed language project, because there also is a VHDL file here. So we have to add the VHDL support to this project, and then you'll see that this VHDL project file is also mapped to the work library, and now it suddenly is no longer unresolved in the hierarchy view here. So there still is an error in that file, so let's press the Control key and we jump from the Verilog file to the VHDL file, and now here we see that for the IEEE library we still need common libraries where these things are declared, and then the project is error-free again. So with that you also see that the hierarchy view includes both VHDL and Verilog files in a mixed language project. Now let's have a look at the libraries view. So this is mostly useful for VHDL projects where you work with multiple libraries. In Verilog you'll probably put most of your files under work here, except for maybe mixed language projects. There you can use VHDL libraries too. For Verilog it's so interesting to look at a class. We have here a SystemVerilog class that we can open in a class hierarchy view, and let's do that again. Okay, there we have it. I pressed the wrong mouse button, I think. So here for this class declaration we see the class members where we can jump right through, and we also see derived classes where we can also immediately jump to the declaration. So this is also a way to browse hierarchy of the classes then. Now, once your project becomes a bit larger, it's always useful to keep an overview on the different files within your project. So here for this SystemVerilog, well, actually mixed language process, because here is also the VHDL file. You can have an overview, and what we see here is all files are in the same library. Now we can just hide the grouping per library, which doesn't really make sense in this case. And you see for each file what the contents of the file is. Now you can just double click here and you immediately move to different declarations in the files, or you can just click to open a single file. For documentation this might already be too much, so maybe you just want to see the files themselves without the design units. And now it's a matter of showing all the files in the project that you see here. You can have the dependencies of just a single file. This one isn't used in the project, but this is one of the top levels that you could see when the dependencies of all files within the project were shown. Also note that files that are excluded from the view or from the project are not shown in the dependencies here. So this is a way to navigate on a rather high level through your project, following the dependencies between different files. Within a file it might also be very useful to get a view on what is happening. Let's have a look at the top level of our DUT here, and I'm opening that one in the block diagram view now. So In this block diagram, you'll get an overview of all the elements of the file. Now it's highlighted on what was selected here. We can also ask to show, let's first select this, show another instantiation in the block diagram. And in here you can zoom and then pan to get an overview visually then of what is available in this file. So if you look here in the outline view, you see that there are two counter instances. There is a DUT core instance and a pixel buffer, and those are the ones that we find back here. So it's also very useful that you can just use the graphics as a way to navigate through your code. So you click an instantiation or a wire or an assignment, and all of them will help you to jump to the correct place in the code. So that helps you to navigate around a project or a file in a very efficient way. Sometimes the information in a block diagram can be a bit too much, and for cases like that you can also manipulate the block diagram itself. Let me close a few windows here. Now we have a bit more space. For instance, these reassignments that you see here, they add little value, so by uncommenting this comment, the reassignments are hidden. A lot of wires, especially for a bus for instance, might be a bit too redundant, so you can also group wires together and show them in a bus structure like we have here. So you can see the contents of the bus just by hovering over something. Here what we're doing with this comment is we're taking the counters and we are grouping them together in a dedicated controller block. So this block doesn't really exist in your code, it's just to improve the graphic here. Optionally, if you want, you can color blocks or groups of blocks in a few different colors. And maybe there is just too much information within this block, just like we did with wires that compose the bus. You can also just collapse a block and show less detail. Now, if we navigate from here by double clicking on the controller, we'll jump to this file. But by clicking the ones that we did not create here, so the pixel buffer and DUT core instances, we'll navigate to the source file. Now, just to keep this layout, I'm going to pin the current diagram view, and now I can double click those and I jump around in the original Verilog file. So you cannot just navigate within your file with these, you can also right click and you can immediately jump to a declaration of a module, or in VHDL of the declaration of an entity or an architecture. So it's also important to note that this block diagram is dynamically generated from your code. So for instance, if we remove this instantiation, it's also immediately removed and now added again to the block diagram. Next to the block diagram, there also is the state machines diagram that's can be very helpful. So in this file we do have a state machine, and here you see an overview of what is happening in a case statement that's further down here. So also here you can double click a state or a transition and you will jump to the correct place in the code. You can likewise select a state here, you ask to show it in the state machines view and it's highlighted up there. So this can be useful for very large state machines. So within the source code here we move to this warning marker. You see here that there is a default clause missing. In this case, let's just suppress that warning. And here you see that there is no outgoing transition from the calculate state. So this probably is a mistake. If I press Control Space, I see the options of which enum literals that are declared. And let's just select the first one, and now we have an outgoing transition from the calculate state. So we now have seen a number of views that help you to navigate efficiently around larger projects, and that will help you just be more efficient when working with these projects. That concludes this part about code browsing. Let's now continue to the next topic about documentation. So when you have a tool that provides documentation, or I must say very often documentation is kept outside of your source code, so you might be using Word or another tool to maintain documentation. But the disadvantage of that is that after you finished working on your design, on your HDL code, updating the documentation yet is another step that requires time and energy spent on maintaining documentation. So what we do is we consider your HDL code as the single source also for the documentation, and documentation can be extracted from that source, because it's easy if you're changing some code, you have the comment on a line above or after the code, and it's easy enough to update the comment at the same time as changing your code. In Sigasi Studio there also is a preview of the documentation, so while you're working on a file and you're maybe adding comments to your file, you can immediately see how this will eventually look in your documentation. And so having this helps you to have your documentation ready at the same time as your source code, and you do not have to spend additional time and effort on maintaining or keeping documentation up to date. We have found that the HTML export, so you can export documentation to HTML using Sigasi Studio, this is a very flexible solution, so you can import HTML in other tools if you want to post-process that. Let's now look at the tool again here, and I'm going to start by opening the documentation preview, which is here. So here we have a module in this file, the DUT engine, and the documentation for DUT engine is shown here. So right now we're just showing the ports in here. But let's take a look at this file, for instance. And here you see that the module description is taken over from the comment lines here before the module declaration. So they are added to the documentation because they are in front of the module declaration. In the port map you see that there are a lot of comments which are taken from the comments which are after the port declarations. And then if we scroll further down, here in the instantiations you also see the instantiation of the RAM instance, where you can have the markdown comments that are in your code. They are here, and then you see that things are processed through a markdown preprocessor. So, and you should note that the comments that are after the ports are not just used in the documentation. because if you hover over a port here, you see that the same comment that was added with the declaration is also present in the hover here. So it really serves multiple purposes to document your code. So once you have all this, let's have a look at how you can export documentation. So when you right-click in the Project Explorer, you can click here Export, and under Sigasi select Documentation. Then you can export documentation for a top level or for an entire project. You can either have the diagrams, which will be added, linked or embedded as SVGs. And once you press Finish, the documentation export is prepared. You see state machines and block diagrams are being generated. And now the documentation opens in the built-in browser window here. It's hyperlinked, so you can click and then you can navigate through the code. So for instance, let's have a look at the pixel buffer we saw earlier. Jump to there, so the description that was there before is now here. You see the effects of the markdown, the comments that were with the ports, and then also the description of the instantiation here. And you can click on this hyperlink too, and you jump to the documentation on our website. So that was it for the demo. So thank you very much for joining this tutorial, and I would invite you to try what you've learned and seen yourself, so on your own code, and to do so you can get your free trial of a Sigasi Studio Expert from this address here.
Well, I guess you can answer the questions that's posted in the chat, if you don't mind.
Can you hear me?
Yeah, we can hear you correctly.
Okay, thank you everybody for joining. And I can see a few questions in the chat. I'll go over them and answer those. So someone asks if the IDE is compiler independent. Well, Sigasi Studio itself has its own built-in compiler, so that's what enables us to show the errors and warnings on your projects the way we do. So even if a file is broken, if your syntax is broken, a regular compiler will quit at the first error. And in Sigasi Studio, you can continue to see as much issues as possible in your code. So no, it's not compiler independent. We have our own VHDL and Verilog SystemVerilog compiler built in. On the other hand, you can configure external tools. For example, if you're used to model sim, you can configure this in Sigasi, and every time you save a file, Sigasi will send your files or the dependencies to model sim in a temporary directory. It will compile the files, and any errors that model sim is reporting, those will also end up in the Sigasi problems view in the editor window, where you have these error and warning icons on the left-hand side, and also in the code itself, the annotation will be there. So that's an additional step, and this also allows you to, for instance, launch a model sim simulation from within the Sigasi Studio hierarchy window. Then a second question I see here. So can the IDE trace signals like DVT? There is some functionality. It's probably different from DVT, but so you can search for all the occurrences of a signal, and you also you can. But that's for VHDL only at this time. So you can do a net search on a VHDL signal. So it's different, but there are certainly possibilities there to find where a signal is being used. And a third question I see is whether Sigasi Studio supports UVM classes and macros. So if you go to our website, there is the Insights website where also the manual is available. And there in the tech article section, we do have an article detailing how you can set up a UVM project in Sigasi Studio. And we also have a class hierarchy browser, so you can browse through the classes of used in UVM in a separate view. And then regarding the macros, there is also a preprocessor view, which I demonstrated. And in this view, you will see all the macro values being resolved as how your code would look after the preprocessor ran on it. I think those are all the questions that are currently in the chat. If anyone else has a question, please ask.
Yeah, for anyone who want to ask, either to unmute himself and ask or type the question in the chat, please.
And if there are no more questions, that's
question. My
yes?
question is how your internal compiler is like we can compare with VCS OMT compiler. For example, we are running a VCS simulator, how we can use your tool with this.
Yes, so well, you can use the tool to explore or create your code anyhow. Currently, there is no direct integration with VCS, so launching VCS whenever you save a file is not supported at this time, but integrations like that are easy to duplicate for another tool like VCS. And so far it depended on customer demand. So there was a lot of traction for ModelSim, QuestaSim, and other tools more than VCS. But if customers ask for it, that will be added too.
Okay, thank you.
Another integration that's possible and that exists now is also if you have dedicated linting tools. So Sigasi Studio does a few lintings and will only ever do lintings that give immediate feedback. But if you're using a tool like alint, which can run for a much longer time, so that's supported also in a similar fashion as an external compiler.
Any other question as we are running out of the time?
Yes, I see one more question. So if you change the definition of a complex data type, like adding a record element or changing the width, we're not showing the impact before you apply it to the file. Further down, if you change the width of a vector, for instance, there is a linting check that will give you warnings or errors that's configurable if the width doesn't match. Okay, if there are no more questions, then I want to thank you all again, and I hope to hear from you.
On this sense, we would like to thank you as well. Thank you for all attendance. I'm gonna close this session.
Okay, goodbye.